Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Welcome. This is Mr. Simon, and we are here to change our world with chemistry. We are still talking about conductivity of solution. We are on lesson number 4. Hope life is good and is treating you very well. Make sure you have your pencil, pen, and paper with calculators. Ready as you follow us in this lesson. So before we continue, we are going to just look at the exercise we left last time. Question number 2. Question number 2 was about plotting a graph, and then so I tried to show you how the graph looks like. That's our graph. It is actually in pencil and pen. So you need to have a title, labeled axis, and at least you try to see how we extrapolated our value here, such that we can be able to get the molar conductivity at infinite dilution, in case they ask it. Yes, they ask it, yeah. So, as our graph, hope you've appreciated it. So you can tell us the value of molar conductivity at infinite dilution. Yeah, it is 245. Yeah. So then they tell you to explain the trend in molar conductivity of strong electrolytes. You know, sodium hydroxide is strong electrolyte, so we say that as the concentration increases, the ions become closer to themselves, then we have a lot of interference. So when that interference is a lot, mobility becomes very, very complicated and difficult. Then we have decrease in molar conductivity. Hope you tried it out. If it was weak, it will be somehow different. Simple difference in the explanations. So today, we are going to say that by end of this lesson, you should be able to explain the relationship or to show the relationship between molar conductivity, and the degree of dissociation. And the degree of what? Dissociation. Yes. So we are going to begin with the dissociation of a weak acid. Dissociation of a weak what? Acid, yeah. So when you talk about degree of dissociation, basically I concentrate on weak acid and weak base. Those are our weak. So when you talk about weak, this degree of dissociation, we need to talk about weak acid. Those are our weak electrolytes. Weak acids, for example, ethanoic acid, and the weak bases, for example, ammonia. So here we have dissociation of weak acid, and we said that from our Arrhenius equation, degree of dissociation is equal to molar conductivity at a given concentration divided by molar conductivity at infinite dilution. Then we are going to say that Ka, which is our ionization constant, is equal to the degree of dissociation times molar concentration. Yeah, this is like a little bit of senior 6 work. But we shall going to use it when you reach senior 6. We can easily find out how these equations come about. Then pH is equal to negative a half log concentration times Ka times Ka. Those are but the best relationship we are talking about is this one, where we have molar conductivity at a given concentration and the molar conductivity at infinite dilution. So we are going to look at some worked example using those relationships. Yeah, we are going to be calculating today in this lesson. So the conductivity of dichloroethanoic acid is at a dilution of 8 molar is that one. Then their molar conductivity at infinite dilution is 385 per ohm centimeter squared, supposed to be per mole. No problem there. So we say calculate the molar conductivity of the acid, of the what? Acid. So if you remember our lesson number 2, lesson number what? 2. Let me get my calculator ready because we are going to calculate in some pieces of chalk. So we are going to say that number 1, we are on worked example number 1. So we are going to do it together. So here they are telling us to calculate the molar conductivity, and we know that molar conductivity is equal to conductivity over C. Then we look at our units. We look at our units. Our units are in centimeters, so we are going to multiply times 1,000. You multiply times 1,000, then you calculate without changing units. Without changing what? Units. So this one is equal to, what is our K? Our K is 0.02 per ohm per centimeter, divided by C, which is 8, times what? 1,000, times 1,000. So we shall have here, shall have 0.023 divided by 8 times 1,000. So our molar conductivity will be 2.875. Then we say per ohm centimeter squared per what? A mole. That is our molar conductivity. Then now we go to the degree of what? This relationship here. The degree of what? Dissociation. So we're going to say that this is, we can call it part A. It's being organized. Then part B. Part B, we are going to say the degree of what? Dissociation. So we are going to use this one, and then alpha. So we say alpha is degree of dissociation will equal to molar conductivity at a given concentration divided by molar conductivity at infinite what? Dilutions. So we substitute. We first see if our units are the same. Yeah, our units are the same, actually. So we are going to say we have 2.875 divided by 385. So our units will cancel. Our units will what? Will cancel. So we say answer. You calculate, try out, and tell me the answer. So me, I've got this one. Our answer will be 7.46. Yeah, 6. Yeah, I always encourage students to write many decimal places, like 4 at least, to make sure we get accurate what? Values. So because it is degree, you can even say 0.0074675. If they tell you in percentage, you say 7. Okay, it will be 0.74675. Cent multiply times 100. Percentage degree of what? Dissociation. So we quickly go to number 2. Quickly go to number what? Number 2. Number 2 is quite more elaborate. They are asking degree of dissociation, okay, degree of ionization, and the acid dissociation constant, or the acid ionization what? Constant, Ka. And then the pH of the acid. pH of the what? The acid. But if you look very well, you recognize that, let's read through the question. The electrolytic conductivity of 1.6 times 10 to the power negative 2 molar ethanoic acid at 20 degrees is, they have given us electrolytic what? Conductivity. You see our units now are in per meter. Then molar conductivity at infinite dilution is that one. 3.5 times 10 to the power negative 2 per ohm per meter squared per mole. Then the first thing is telling you to calculate the molar conductivity of the acid. So we are going to do the same as we have done here. So we say our A, we are going to do like this. Our molar conductivity will equal to K over C. So because it is in meters which are multiplied times 1,000 down, We talked about this, if you remember. Then we are now going to substitute. We are going to substitute. So we have our K as 1.96 times 10 to the power negative 2 divided by C, which is, you can tell me and we move faster, times 10 to the power negative 2 times what? 1,000. So if we are a mathematician, we can cancel these two. Then we say 1.96 divided by 1.6 divided by 1,000. So our value of molar conductivity will be 1.225 times 10 to the power negative 3. So here we're going to say per ohm meter squared per mole. Per ohm meter squared per what? Per mole. So you see the units are changing somehow. So then the degree of ionization. We can talk about the degree of what? So our degree of ionization will equal to molar conductivity at any concentration divided by molar conductivity at infinite what? Dilution. So here we are going to begin with this one. We have calculated the value times 10 to the power negative 3 divided by, we have also 3.5 times 10 to the power negative what? 2. Negative 2. Yeah, negative 2. So you calculate, tell us the answer. Calculate very quickly and tell us the answer to see that we are here on the same wave. Yeah. So our value will be 0.0335. That is our degree of dissociation. Then we continue and we talk about the Ka. So Ka is going to be given by, this Ka value will be given by alpha squared C. Degree of dissociation times the concentration. So we shall have 0.035 squared times what? C. What is C? C is 1.6 times 10 to the power negative what? 2. Negative 2. So what will be our value? Let's go down here. So we have this squared times 1.6 times 10 to the power negative 2. So which answer have you got? Me, I've got this one. Hope we have the same answer, times 10 to the power negative what? 5. So what the units for Ka is molar, moles per decimeter. Then from there, so we see we are using a lot of formulas here. We get the pH. So we say pH for a weak acid. pH is equal to negative ½ log CKa. So this will equal to negative ½ log 1.9, no, actually is 1.6, yeah. 1.6, yeah, let's change this one. 1.6 times 10 to the power negative 2. I was looking for a duster, but we can continue. 1.6 times our Ka, which is 1.96 times 10 to the power negative what? 5. Yeah. Then after we calculate. So we have 1 times 1.6 times 10 to the power negative 2. Then negative log answer and divide by 2. So our answer will be 3.25. So this is the pH. That is the what? The pH of our solution. Yeah, pH of our solution. So hope you followed and you've seen how we have used our expressions to calculate. You just look at our answer. This is our answer. This is our answer. Maybe you can make this one look better by putting 6, nice 6, such that you can copy or make a good screenshot. And you follow very well. So let's go and talk about when we have dissociation of a weak base. Dissociation of a weak what? A weak base. A weak bases, for them, they dissociate differently. Instead of using pH, they use POH. Why? Because of the definition of bases. You know, when bases, from the definition of bases, we observe that bases are, we have 3 definitions of bases. One, Arrhenius definition, where we have bases dissolving in water to give OH ions. Then we have bases also as proton acceptors. We also have bases as lone pair donors. So we basically concentrate on that OH bit of it. OH bit of it. So instead of using pH, we are using PO what? POH. So what is POH? POH is negative low concentration of hydrogen of OH what? Ions. Negative low concentration of OH what? Ions. So, but for when in our calculations we say that POH will equal to negative a half low concentration Kb. So instead of saying Ka, this time we are saying Kb. And pKw is equal to, what is Kw? Kw is the degree of dissociation of water. That P normally comes in as negative log. So like, for example, is Kw, if we say pKw will be equal negative log K, like that. So it's negative log. You see, even when we have pH, pH is equal to negative log concentration of hydrogen what? Ions. Then the POH is equal to negative log concentration of OH what? Ions. So you see what we have. So it's mathematical expressions. I know the reason why they used it to make our values readable, and we can base on them, especially in our daily lives, especially like pH. If someone says pH of water is 7, and another person says the concentration of hydrogen ions in water is 1 times 10 to the power negative 7, you observe that some are more complicated. So it is easier for you to get 7 than getting 1 times 10 to the power negative what? 7. So we are going to use these things in our calculations. So in senior 6, you shall learn how to prove these things. So let's continue quickly. So we have an example here. We have an example. So the example is telling us that the electrolytic conductivity of a solution of 0.1 molar aminoethane. So aminoethane is a base, is that one. Then if the molar conductivity of aminoethane at infinite dilution is that one, calculate the molar conductivity of the base. The molar conductivity of the what? The base. So now we are going to calculate. We are going to calculate. We have the same. So here we have another example. So we can call it for dissociation. Dissociation of a weak base. And you said we are going to use OH because of the definition of who? Because of the definition. Because of the what? Definition. So we are going to say that now that A, we are going to say molar conductivity is equal to K, and now we have enough experience over C. So we look at the units, the units are in meters. So we are going to divide this one by 1,000. So we continue here and we get our K. You can tell me the K and we move faster. So our K is 1.5 times 10 to the power negative 10 divided by C. C is 0.1. Today our C is very nice. Very, very nice. It is easy to recognize. So let's put it down here. So you can help me to calculate that value. Help me to calculate that what? Value. So we can even use, these people who are mathematicians can tell us the answer even before we calculate. So divide by 0.1, divide by 1000, yeah. So our answer will be 1.5 times 10 to the power negative 4, we say per ohm meter squared per mole. Then we go to B. You see these questions, when you fail the first one, the others become useless to do. So now we're going to talk about the degree of ionization of a weak base. Degree of what? Is the same. It's the same, we don't change. So we have our 1.5 times 10 to the power negative 4 divided by the molar conductivity at infinite dilution, which is 2.04 times 10 to the power negative 2. Yeah. So we can also come down here, or we go in front. That's good. Okay, it's okay. So we have divide by 10 to the power negative 2. Divide by 2.04. So we have our answer as, so I'm going to write some of the decimal places, like 4, 7.35529. There is no unit, times 10 to the power negative 3. Yeah, times 10 to the power negative 3. So we have our value. So it's good to check your answer, because these answers are very determining. Very, very determining. If you make a mistake in the first one, the rest is what? Wrong. So you need to check it very well and also apply speed. So then base dissociation constant. Base dissociation what? Constant. So our base dissociation constant will be, shall say that is equal to Kb, will also equal to alpha squared C. So we say 7.3529 times 10 to the power negative 3 squared times 0.1. This is very nice. I like 0.1 because it is easier to use. So we square, then times 0.1. Yeah. So we shall have our Kb, the base dissociation constants at this one. Let's write more decimal places. Let me include 0, 6, and approximately 6 is 5 by 6. 10 to the power negative what? 6. So this unit is from this one, from that one. So we continue. So we want the pH. Want the pH. Want the what? The pH. So we have so our pH, we say the pH, we shall get it from pOH. pOH. So pH, we shall get it from pOH. So we shall say pH is equal to pOH. Saying that our pH is equal to pKw minus pOH. So this pKw is always a constant, and always equal to 14. So we can as well say that pH is equal to 14 minus pOH. So we are going to find the pOH. So how do we find pOH? We said from the definition, pOH is equal to negative ½ log Kb. So we can substitute very quickly negative ½ log times 0.1 times 5.4066 times 10 to the power negative what? 6. Then we can do like that. Then we say 0.1 log. So our value will equal to 3.13. So that is our pOH. So but but pH is equal to 14 minus 3.13. So our pH will equal to 14 minus 3.13, which will equal to 10.8 what? 7. So when you are calculating pH, especially of bases, you should recognize that they're always above. They're supposed to be above 7. So when you have your answer and it's not above 7, it means your answer is what? Wrong. Hope you followed us. We have many equations here, which you need to take note. Take note, yeah. Take note, yeah. So here we have an exercise. I want you to try out this exercise. So the exercise I'm going to leave you with today is about these calculations we have been doing. And the first question says that the electrolytic conductivity of 0.1 molar propanoic acid is that one. Then molar conductivity at infinite dilution is 3.91 times 10 to the power negative 2 per ohm meter squared per mole. Then calculate the molar conductivity of the acid. Then you have seen what we have done. I think you can look at this one. A good example of what we have done. Calculate the molar conductivity, units are in meters. Then degree of what? Dissociation. Then the acid dissociation constant, Ka. I told you we shall prove this, especially when we study in senior 6. Then pH also. I think it's very easy. You will not fail. You will not fail. I'm sure of that. Then we have another question. You can copy it, or you can copy the first one. It's similar to the first one, but this time we are saying that a solution containing 6.7 grams of weak acid, if relative formula mass is that one, that is volume. So it means the students are supposed to be able to find the molarity from volume and molar mass and the gram given. Then the electric conductivity is given, then the molar conductivity at infinite dilution is given. So you need to find the molar conductivity, then after degree of what? Dissociation. The same way you do it. The first difference here, you need to find the C. To find the C. Okay, thank you very much for following me today. Hope you can be able to calculate these things you have calculated today. We shall meet next time. God bless you very much.